Not only is Mark Twain brilliant by basically every metric, the guy was pretty hilarious too, and he has all these witty quotes that are just so on point, including this one. And if you don't believe that's true, just ask the folks here in View Park, Windsor Hills, California that woke up to a pretty big Earth Day surprise. Geology does get more interesting the day after the earthquake, just like viruses get more interesting during a pandemic, right? And earthquakes are happening all the time, millions of them. Here's what we're up to, you guys. Earth science is part of environmental science. It's part of the scope of our course. I think the course is just so broad. The first few years, I didn't even touch on earth science. And I was thinking that, it's the one area that people really aren't impacting that much. We're not moving the plates and causing volcanoes, although I suppose with fracking, we're starting to have seismic activity. But then, of course, one of the years it backfired, and it was one of the FRQs. Oh, so never again. So we're going to just do a quick little plug here. This is a geology crash course. We're going to go over these different areas here. And that the interesting thing about geology is it's a newer science, or at least we're understanding more and more. And so you guys have all seen this, like Pangea, right? We're all aware of that concept, but your grandparents didn't learn that in school. Can you imagine what it was like when people started talking about continents moving? Like Africa can move? How? Right? So there's big questions here. And so we're going to be taking a look at all of that right now in our geology crash course. I've got a very high-tech demo I want to show you for this first part. By the way, if you don't have this, make sure you print it out or do your best to copy it down. It's linked in with Canvas. But we're going to take a look at the structure of the Earth. Here's my high-tech demo. Boom. And the reason I like this is because the skin of this apple is the thickness of the crust, aka the lithosphere, the sphere of rock that where we exist with all the overburden. Right? And so, but just look, there's, it's our experience, but of course the Earth is much more than that. So what's going on down here? We've got the mantle, right? We've got the outer core and the inner core. And I know all you California kids know some geology, being that we live on a fault, basically. This is review for you guys. And so think about the mantle is like thick, viscous, like oatmeal. Thickest oatmeal ever. Way too thick to eat. But it's not consistent all the way through. But we get convection happening here. And convection, we've talked about before, is happening in the air, right? This is why air circulates. Warm air is less dense, it rises, it cools, cooler air is more dense, sinks, and you get this cycle happening. It happens in the water. Same concept, and now here it is happening in the rock. That was a huge breakthrough in trying to explain how these plates move. How does Africa move? Answer, convection cycles in the mantle. We've got the outer core, which is liquidy, and then the inner core, which is solid, mostly nickel. How they figure all that out? It's pretty cool and beyond the scope of what we're doing right now, but it involves using, shooting basically sound waves into the earth and measuring how long it takes and watching where they go and do they bounce and that kind of thing. How did it get so hot down here? It's just all that pressure. There's nuclear reactions, and that is the source of the heat that is making it so this bottom part gets hot and comes up here. And so you can pause, take a look at this, but I'm going to move on. This is a really good video that shows convection happening. It also shows something we're going to talk about here in a minute called subduction zones. And so we'll come back to that. But for right now, just take a look at this 1 minute video. If I can get the thing to start, it's pretty great, I think.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, This layer of rock is heated, so the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere during an eruption.
And there we have it. And so just when you think of those convection cycles, think of it as like a conveyor. And the wheels are moving and the belt goes along the top. It's like that. And so there we have it. I would make a note here by driver of movement. You want to understand how convection cycles work in the mantle. Okay. And then this is a map of our tectonic plates. And there's something that I'm sure a lot of you guys have heard of, and especially if you're a Johnny Cash fan, called the Ring of Fire. And the Ring of Fire is basically this, right? Why is it the Ring of Fire? It's because this is where all the volcanoes are going around here. And not only volcanoes, you get earthquakes and stuff too. So there's just a lot of tectonic activity. Why? Because that is the border of our tectonic plates. And here in California, here's the San Andreas Fault. I know it's a little bit blurry, but as you're driving on 280 towards San Francisco, you guys, and it's a beautiful drive. It's a great freeway as far as freeways go, and you're driving right along the boundary between the North American Plate and the Pacific Plate. It's remarkable. When we were at Jasper Ridge, we were right by the San Andreas Fault. So we're going to be moving into plate boundaries right now. And I'd like to do this in class, but oh well, I guess you're going to have to get Oreos on your own, because here comes my next demo. Actually, I'm going to pause here for 1 second. These are all the earthquakes that have happened in the last day. There's 65 earthquakes according to USGS, and look at where a lot of them are happening along the Ring of Fire. Not all of them, because there's some that are not on plate boundaries, which is interesting, but most of them, if you look at them, they're really close to a plate boundary. Okay, so here we go with our first type of plate boundary. It's called a divergent boundary. What do diverging things do? It's the same thing as dividing or divorcing. They are separating. And so I've got my Oreo cookie here. This is my model. I'm very carefully, I've been trained, I'm pulling off the top cookie. I'm going to break it in half, and I'm putting it down here. So here's my cookie again. I've repaired it. What does this top part represent? You're right, it's the lithosphere, or the crust. And what's the white part? It's the mantle, and I guess we could say this bottom part of the cookie is the solid inner core. And so here we go. Hang on to your chairs. I'm going to demo seafloor spreading. So basically, just like in this picture here, you've got magma erupting right there, and that magma pushes, it pushes the plates apart so they diverge. But of course, if they're diverging here, they're going somewhere. And so, quick little quiz question for you guys. Where is the biggest mountain range in the world? You're right. It's a trick question. You can't see it. It's not the Himalayas. It is the Mid-Atlantic Ridge that goes right through here. It's the longest range, and you can see those little arrows going out there. That's because that is the diverging plate boundary. You got, and that's actually, interestingly, the newest rock is right there too. If you wanted to find brand new rock, it just erupted. It's like constantly erupting, pushing out. That's what that is. Demo number 1. Okay, here comes the next one. And you saw this in the video. Here's my same cookie. So if it's not diverging, going out, it's converging, convening, or coming together. And so there's 2 types. One is what you just saw in the video. It's called a subduction zone. And so you've got 2 types of crusts that are coming together, and one is subducted under the other, like that. One goes down, is subducted. If you get abducted by aliens, you go up. If you get subducted like a submarine, you go down. The ocean crust is actually thinner than the continental crust, but it's more dense. And so when they come together, the most dense thing goes down. That was a good thing in the video if you want to rewind and see what it looks like again. But my friend Cindy Wilbur from Jasper Ridge says it's like this. It's like taking a pizza and shoving it under a door, and all the like stuff on your pizza gets stuck on the door. And so as these things subduct, all that rock gets scraped off the top of the crust, and then especially in California, you end up with weird rock all over the place. Where did it come from? Subduction zones from like millions of years ago. So that is boundary number 2. Here comes boundary number 3. Let me go to the slide. There's one other type of converging boundary, and it is when you've got 2 types of continental crust that are coming together and they're the same density. So they don't subduct. And what happens is it's a tie, and you get really big mountains like that, like the Himalayas. That is continental crust to continental crust, another type of converging boundary. By the way, quick fun fact, the Appalachians in the east coast of the United States used to be taller than the Rocky Mountains. They used to be really big, they just got worn down over time. Okay, I got one more to show you here, and this is the one that earthquakes happen along. So we've got the diverging, we got converging, and now we're doing what's called a strike-slip fault. They slide by each other. It's also called a transform fault. It's the last one on your page. So basically you just got 2 things like that, and then they're stuck, there's friction, and then finally they go. And as soon as it releases, that's when you feel the earth move. Like the energy is released and it shakes the earth. Do you want it happening, do you want lots of little earthquakes or just a few of them? Right, lots of little ones. You want to have that pressure constantly being released so you don't get a huge mother earthquake that crushes you. And so those are our 3 types of boundaries. Then we've got the rock cycle, and we had some great demonstrations on this at the beginning of the year. You're not going to have to memorize this, but no, rocks can get converted from one thing to the next. And the thing that I wanted to pause on here is as rocks get weathered down, and we talked a lot about erosion this year, in those particles, those sediments, there are nutrients in there. And so when those sediments get moved, it's really important, and sometimes it can cause problems and it can make water cloudier than you want it to be. But one of the things that we want to think about, and I think this is right for an AP FRQ, is where do those sediments go? As those sediments wash down mountainsides, they come in rivers and you get floodplains. And periodically, those waters completely flood, and when they do, they drop the sediments. There's nutrients in those sediments, and so that's why around rivers like this in the floodplain, it's really fertile land for agriculture. That's really important. And so when we build dams and things like that, we stop the flow of those sediments, and it has an impact, right? We just need to recognize that. And so those are the big pieces I wanted to go over. Oh, one more, I forgot. Hot spots. What about Hawaii? Hawaii's not on a fault, on a plate fault boundary. You get hot spots that develop too, and as the plate moves, even though it's not on a boundary, if my finger's a hot spot, as it moves, it makes little volcanoes, right? And so that's what Hawaii is. It's just a chain of volcanic islands because it keeps going over a hot spot right there, chain of islands. Okay, you guys, that was the geology crash course. Hopefully that was interesting to you. If it wasn't, the day after the next earthquake, it will be. But hopefully we don't get that for a while because we got enough to deal with right now. All right, thank you. Make sure you fill out the Google form.